All right, Mr. Austin back with you. Lesson 4.2 today is covering standard form, vertex form, and intercept form. Now, standard form we've already talked about, but vertex and intercept form are two new forms that we're going to see today. So let's go ahead and get started with standard form. For standard form, we know that it's going to be written in the form of y equals. So we'll go ahead and write it off to the side here. Next to standard form, so that you'll have all the forms. Y equals ax squared, we've seen this before, plus bx plus c. So ax squared plus bx plus c is what we call standard form. So you can see right here that in this form that it's been given to us in, that we've already got identified our a, which is 2, our b, which is -8, and our c, which is 6. So we're going to use our formula that we already know to find vertex, which is x equals -b over 2a. And knowing that we already have the numbers for a, b, and c, we can go ahead and just plug in. So we can see that it's -b, and b is -8, so that's going to make b 8 over 2 times a, and a is already 2, so 2 times 2 is 4. So there's our x value. Our x value equals 2. So we're starting to find our vertex, basically, is what we're looking for. And we've just found the x value for our vertex point, so let's go ahead and just write it down right now. You know, it's going to be 2 something. Now remember, once we find the x value, we plug in that x value here and here for our x's so that we can calculate what y equals. When we do that, y is going to equal 2 times x is 2, so 2 to the second minus 8 times 2 plus 6. And when we do all those calculations, you're going to end up with -2. So we just found our vertex point. That's at 2, -2. I'm going to go over here in red, go ahead and plot that. That's at 2, -2. There it is. All right, let's come back over and label a few more things. Let's talk about the axis of symmetry. Again, I'm going to abbreviate. The axis of symmetry, since that is my vertex point, we know that the axis of symmetry is the vertical line that passes through that point, which is going to be here. That's my axis of symmetry, and you can see that clearly it goes through 2. So we can say that our axis of symmetry is where x equals 2. A value is positive, which means this is going to have a minimum value. And since we know the y value of our vertex point is at -2, that tells me that my minimum value is y equals -2. Now, when I go to graph this thing, I'm going to go ahead and just sketch quickly a little table here. And I already know that 2, -2. Again, you could plug this into your graphing calculator and get all this information. I'm just going to give you some points. 1, 0, 0, 6. Then we got 3, 0, and 4, 6. And I'll quickly plot those. I got 1, 0. I got 3, 0. I got 4, 1, 2, 3, 4, 5, 6. And I've got -2, or I'm sorry, 0, 6. And clearly we can see that when I graph this parabola, here's what we're looking at. Opens up. And that means when I take a look at the last couple things I want to give you, the domain for this parabola, we know that this parabola goes on forever to the left and to the right, so the domain is all reals. And the range, we know that this parabola bottoms out right here. Bottoms out at -2 and goes upward forever. So that means that our range for this thing is all of the y's that are greater than or equal to -2. So there's the information we know when it's given to us in standard form. All right? A lot of work that we have to do there in standard form. So let's take a look. What happens when they give it to us in vertex form? Well, first of all, what is vertex form? Let's go ahead and give you that. Vertex form is y equals a, which we've talked about that a lot, times the quantity x minus h in parentheses squared, and then at the end plus k. Now we've seen this form when we talked about the absolute value. And we know some things here. We've talked about a, h, and k before. Just a quick recap. A stretches and compresses. A also tells us whether it opens up or opens down. H moves it left and right, and don't forget, H lies. And K moves it up and down. So, first thing I want to identify here, obviously when I'm graphing these things, is the vertex point. Now, if you remember from previous lessons, when we have something in this form, finding the vertex is really easy. Reminder that the vertex is simply h, comma k, remembering that h lies. So in this case, we've got x plus 3 inside parentheses, which tells me that when I go to write the vertex, it's not going to be plus 3, it's minus 3, because h lies. And k, in this case, is 4. So notice we didn't have to do any work at all, and we just look at the equation and we get our vertex point. That's what's nice about vertex form. It's actually just given to you as long as you know all the tricks. So I'm going to go over here at -3 and 4 and put on our vertex point. There it is. All right. Now the a value you'll notice in this is -1/2. At -1/2. Well, remember, that's going to tell us something. If it's negative, that means that our parabola is going to be opening downward. Keep that in mind. Let's go ahead and jot in, since we do know where the vertex point is, we can go ahead and draw in the axis of symmetry. There it is. And our axis of symmetry here is that x equals -3, easily seen on the graph. Since we said we know that this thing opens downward because of the negative a value, that also tells me that means we've got a maximum value here. And remember, to find the max, all you have to know is the vertex point, and we do. It's the y value, the vertex point. So where's this thing max out? It maxes out at y equals 4. Also, I'm going to jot down real quick, table of points. Again, you can plug this in on your calculator and get these quickly. We got -3, 4, which is my vertex. I got -2 and 3.5. And then I've got -1, 2. I've got -4, 3.5. And -5, 2. So let's plot these here real quick. We got -1, 2. Got -2, 3.5. I've got -3, 4, obviously, and then I've got -4, 3.5, and then I've got -5, 2. So my parabola is looking something like this. Now I've got my parabola. I can see, okay, well, first of all, let's do the domain. Domain, again, it goes on forever left and right, so it's all reals. And my range this time, come in here with a green line and say, well, yeah, this thing actually tops out right here at +4, and it goes downward forever. So that means my y values have to be less than or equal to 4. And you'll notice that we were able to find information much quicker when you give it to me in vertex form, because once again, in vertex form, you know the vertex right away without doing any work. That's a pretty quick way to be able to find information on a parabola. We like it in vertex form. The last form we're going to take a look at is intercept form. And let me go ahead and give you the intercept form. It's y equals, once again, a, and then we've got parentheses x minus p, new variable there introduced. We'll talk about what it is, and x minus q. All right, so p and q in this case are basically our intercepts. So you can see here that in this format that we're given, that x plus 2 and x minus 4 is in my parentheses. Once again, because they're in parentheses, they're going to lie to us. Because in order to find out what they are, we would set them equal to 0. So here's what that tells us. In the first case, this first parentheses right here, and that's our first parentheses right there, that tells me that p is going to equal -2. And then the second one, that's this one and this one, that tells me that q is going to equal +4. Because again, they lie. So now that we know that, here's what else we know. We know in this equation, given this information right here, we know that a is negative, and it's -1. So here's what we know about x-intercept form. We know that we're given the intercepts. The x-intercepts are p and q. Here's what else we know, that the axis of symmetry. If we think about this, if we know the x-intercepts, let's place the two x-intercepts on the graph. So we said one is at -2, so that's here. And the other one is at +4. That's here. Now think about it. If that's where the parabola crosses the x-axis, right in between those two, in the middle of those two, has to be our axis of symmetry, which means our axis of symmetry is, let's finish this sentence, is p plus q divided by 2. Basically, we just want to find what's in between those two dots. And when we do that, we've got p plus q. Well, that's easy. We've got -2 plus 4 divided by 2. And that's going to give me 1. So I'm going to go over to 1. And I'm going to say, well, that's going to be the middle of my graph. Right here at 1. Yeah, 1 is the middle of my graph. Now, if that's the case, I know the axis of symmetry. That means the axis of symmetry is at where x equals 1. And I've got it written in on my graph already. All right, well, if we know that, let's try to find this vertex. Well, I already know that it's 1 over 1. Let's go ahead and label vertex. And I already know that the axis of symmetry is at 1, so I know it's got to be 1 something. And remember, if I know that x is 1, I can come right up here to the equation here and put 1 in there. And then just simply figure out what y is. So y would equal negative times 1 plus 2 times 1 minus 4. And calculate that out. And when I calculate that out, I find out that y is going to equal 9. So that tells me that I know the y value of my vertex. It's 9. So now I know my vertex is at 1, 9. So I'm going to go over 1 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And place my vertex point. All right, so clearly I can see that this graph is going to do this. Makes sense because my A value is negative. It's going to open down. If it does open down, that means I've got a maximum value. And my maximum value clearly is at 9. My maximum value is at 9, as you can see, because 9 is where this graph tops out. All right, last thing I want to do is let's do the domain. Again, it's all real numbers because it goes left to right on forever. And then the range. The range, we already said it tops out at 9 and goes downward, so it's all the y's that are less than or equal to 9. And that's how we find the necessary information when we're given a graph that's in intercept form. So now that you've seen all three forms, you choose which form would you like to have a parabola in.